Example 1. Find the expected value, mu, of the following discrete probability distribution. A discrete probability distribution is valid if and only if the probabilities of all the outcomes lie between 0 and 1, and that is the case here. And also, the sum of all the probabilities must equal 1, and that is also the case. Now, to determine the expected value, mu, and by the way, mu represents the population mean. The sample mean is represented by x bar. We'll add another row under the table. We'll call that the XPX row. So that's a score multiplied by its probability. And we'll determine that for each of the columns. This is similar to the FX column in a frequency distribution table. So 1 multiplied by 0.2 equals 0.2. 2 multiplied by 0.15 is equal to 0.3. 3 multiplied by 0.15 is equal to 0.45. 4 multiplied by 0.1 is equal to 0.4. And 5 multiplied by 0.4 is equal to 2.0. Next, we sum this row, the sum of the XPX row, and the value that we get is the expected value, or mu. So it can be represented using sigma notation. So mu is equal to E of x, which is equal to the sum of the XPX row, and that equals 3.35. Example 2. Find the variance, or sigma squared, of the following discrete probability distribution. The variance is a measure of spread or dispersion of the scores in relation to the mean or the expected value. Now, the expected value of this distribution was already determined in example 1, and that was 3.35. So what we're going to do here is we're going to add an extra row to this table. So we've already added an XPX row from example 1. Next, we're going to add an x minus mu all squared row. And these values are determined by taking a score, say starting with 1. We subtract from that mu, 3.35, and then we square it. So 1 minus 3.35 all squared is equal to 5.5225. 2 minus 3.35 all squared is equal to 1.8225, and so on. So we end up with these 5 values. Next, we can determine the variance by using this formula. So sigma squared is equal to var x, so they mean the same thing, they refer to the variance, and that's equal to the sum of x minus mu all squared multiplied by the probability of x. So what we're going to do is we're going to take each of these values, we're going to multiply each value by its respective probability and then add them all together. So 5.5225 multiplied by 0.2, so that's this value here, plus 1.8225 multiplied by 0.15, that's this value here, plus 0.1225 multiplied by 0.15, so that multiplied by that, and then plus that multiplied by that, and this value here multiplied by this value there, to give us this expression here. So adding all that together, so evaluating that, we get 2.5275. And that's the variance. Now, just as a side note, the standard deviation, let's get rid of that glare there. The standard deviation is just the square root of the variance. So the variance was 2.5275, take the square root of that, and that gives us the standard deviation, which is around 1.5898. Here is an alternative method of determining the variance, or sigma squared, of a discrete probability distribution. Now, previously, the variance was worked out by firstly determining the difference between a score and mu, squaring that, multiplying that by p of x, and then adding all that together, which is quite time consuming. The alternative method uses this formula here. Sigma squared is equal to var x, which is equal to the expected value of x squared minus mu squared, or the expected value all squared. But before we use that formula, we're going to add a row to this distribution, which is the x squared px row. So it's very similar to the xpx row, except we're going to square the score and then multiply that by the probability to determine these values. That will then determine the expected value of x squared. So the square of the score multiplied by its probability, and all that is summed together. So x squared px is found by taking the score, squaring it, and then multiplying it by the probability for that score. So 1 squared multiplied by 0.2 is 0.2. 2 squared multiplied by 0.15 is equal to 0.6. 3 squared, to 9, multiplied by 0.15 is equal to 1.35. 4 squared, 16, multiplied by 0.1 is 1.6. And 5 squared multiplied by 0.4 is equal to 10. So summing this row, so 0.2 plus 0.6 plus 1.35 plus 1.6 plus 10 is equal to 13.75. And that corresponds to the expected value of x squared. Now to determine the variance. So sigma squared is equal to var x, which is equal to the expected value of x squared, which we now know, 13.75, minus mu squared. And mu is 3.35. So that's 13.75 minus 3.35 all squared is equal to 2.5275, which corresponds to the answer in the previous method.